is instead of making the graphs from the equation, we're making the equation from the graph. So you'll be given a graph, and your job is to figure out what possible equation it might represent, okay? So for the warm-up, it kind of breaks down like how we're going to do this process step by step. And then for the rest of the examples, we'll kind of shorten it up just a little bit. So first, this first one on the left, it says, is the degree even or odd? Let's look at our end behavior. It has two arrows pointed down, same direction. Would that make our degree even or odd? Even. They're the same. Even. Okay. The right side of my graph is pointed down. So is my leading coefficient positive or negative? Negative. So just kind of that backwards thinking. Last time we said, okay, even and negative, and we created our end behavior. This time we're given the end behavior. The next part says, what are the zeros? So if we zoom in on our graph here, I'm looking at where my graph crosses the x-axis. So what's one of those values? -1, okay. What's another one? 2 and 4. Okay. So those are my three zeros. We have x equals -1, x equals 2, and x equals 4. It also says to include the multiplicity. That's the part that we kind of have to think about. And again, kind of backwards thinking. For example, at -1, our graph bounces. Does that mean our multiplicity is odd or even? Even. And this is just like a normal bounce, not stretched out or flattened in any way. So what do we think the multiplicity is? 2. It's even, and it makes that U shape. The multiplicity is 2. If we look at x equals 2, this one goes through that 0. So is my multiplicity even or odd? Odd, because it goes through. And this one goes through with like a little squiggle. What do we think? 3. Not 1, because it's not a straight line through, but 3, because it has a little squiggle. Okay? Down here, this means multiplicity is 2. M equals 2. Just shorthand. And then my last 0 is 4. It goes straight through. Is that even or odd? Odd. And it's just straight through, no squiggle. So 1. Okay? So instead of graphing them, we're looking at the graph and working backwards to find the multiplicity. In general, any graph that I give you, none of the zeros are going to have a multiplicity greater than 3. Okay, so if you see a little squiggle that still goes through, it's going to be 3. Okay, I probably won't give you any 5s or 7s or anything like that. Okay, so now we have our zeros. Let's write our zeros as factors. So for x equals -1, what's my factor? X plus or minus 1? Which one? Plus 1. We change the sign, right? For x equals 2, if we change the sign, that goes with x minus 2. And then for x equals 4, we change the sign. That's x minus 4. Now we have to worry about our multiplicities. This factor should have multiplicity 2. Where should I put this 2? Like, how do I write that into my equation? It's in the exponent. Perfect. So we have a squared. We have a x minus 2 cubed for my multiplicity of 3. And then my multiplicity of 1, I can just leave it as is, or put a 1 here if you wanted to. Okay? This is a very general form of this graph. If I were to sketch this, I could get this. But I might not get this exactly. What we need to do is we need to figure out if there's a number in front. We know all of these pieces are right. The only thing that we can possibly change is our leading coefficient, okay? It might be, we know it's negative, but it might be -2 or it might be -10. We don't know. And our job is to find it, okay? So that's going to be the only almost tricky part for writing these equations, bless you. And it kind of relates back to Algebra 1. What we're going to do is we're going to just put a variable in here for now. Let's call it A. Our leading coefficient is A, okay? We're going to take a point off of our graph. This one, they give it to us. We take a point off of our graph. And what we're going to do is we're going to plug it in to find A. So I'm going to plug 0 and -4 into X and Y to get A. You probably did this a lot in Algebra 1 when you were trying to find B, like your y-intercept, okay? If you are given a point to plug in, use that point. If you have to find a point, pick a point on your graph that makes your life easier. Pick like X equals 0 or X equals 1. Don't go too far left or right of the origin. It's going to make more room for error, okay? So pick a nice, easy point. So if we take that point, 0, 4, I'm going to change all my x's to zeros, and I'm going to change my y, or my f of x, to -4. So -4 is equal to A times 0 plus 1 squared, 0 minus 2 cubed, and 0 minus 4. And this is why it's really nice to plug in 0, because we can just kind of drop them, and we get 1 squared, -2 cubed, and -4. Okay. Again, we're just solving for A. So what I'm going to do on the right here is multiply all of these out. You could just dive straight into your calculator. That would be fine as long as you are extra careful about parentheses, especially around negatives, okay? So I'm going to do it by hand just for good practice, but -4 on the left, 1 squared is 1, -2 cubed, what would that be? -8, and then -4. -8 times -4 is a positive 32. Times 1 is a positive 32. So we have 32A on the right. Last step, and this will always be your last step, we need to divide off this 32. So divide both sides by 32. We get A is equal to -4 over 32. What should I rewrite that as? How can I simplify this fraction? What can I divide the top and bottom by? More than 2. 4, very good, 4. And this would change to a -1/8. I've done all the work now. I just need to take this equation that I originally wrote and change that A back to what A actually is. So my final answer is I have -1/8 times x plus 1 squared, x minus 2 cubed, and x minus 4. And you can kind of just double check again, add up your degree, and we get an even degree, and our leading coefficient is negative, which matches our end behavior in our graph. So 3 kind of steps here. Find your zeros and their multiplicity, write them as factors, plug in a point to find A, and then like rewrite your equation for your answer. Questions on that first one? Okay, let's do another one. This one, our end behavior is towards negative infinity, so it's pointed down on both sides. And it's the same on the left and the right. So is my degree even or odd? Even. And the right-hand side is pointed down, so my leading coefficient is negative. So when I'm done, I can check these two pieces pretty quickly if I wanted to. Now I need my zeros. I have 1 at -1. And this 0, it bounces off of it. So is my multiplicity 1, 2, or 3? What do we think? 2. It's even because it bounces. And I'm probably not going to give you anything higher than 2. My next 0 is x equals 2. And it goes through this 0, but at a squiggle. What do we think my multiplicity is? 3. Goes through, so it has to be odd. Squiggle means it's more than 1. And then my very last one, x equals 4. It goes straight through that 0. What's my multiplicity? It's 1. It's odd because it goes through, and there's no squiggle. So it has to be 1. Step 2, write those zeros as factors with the multiplicity in the exponent. So we have our function is equal to, we would have, if we change all the signs, x plus 1 squared from this first piece, x minus 2 cubed, and then x minus 4 to the first. So if you look, our zeros, and actually everything up to this point is the exact same as that first graph we did, but they're not the same graph. So that's why we need to find A, because this does not accurately represent my graph. We need that A to kind of distinguish the difference between these two, because they still have the same zeros with the same multiplicity, but we need that extra piece of detail. Okay, so we need to find A using this point right here, 0, -2. So we're going to plug in to find A. -2 is y, or f of x, same thing. So -2 is equal to A. And then all my x's are zeros. So this is where it gets a little handy if you pick the point where x is 0. Because 0 plus 1 is just 1. 0 minus 2 is just -2. So I'm going to plug them in, but I'm really just going to drop the 0 and kind of do it in my head. I'm plugging in 0, but 0 plus 1 is just 1. I'm plugging in 0, but 0 minus 2 is -2. 0 minus 4, -4. Again, same exact situation we were in for this problem over here, at least on the right-hand side. This right-hand side came out to 32A. So now we have -2 is equal to 32A. Divide by 32. What would this fraction reduce down to? What can I divide the top and bottom by? 2. And I would get -1/16. So my equation is the exact same, but my A, instead of -1/8, is -1/16. Okay? So the factors are not necessarily enough to define your graph. You need to have that A value. And we get it by plugging in a point. questions on either of those two? So again, something that might be handy to write down are your steps. Step 1, find your zeros. Step 2, write your factors, including multiplicity. So write your factors with the exponents. Step 3, we plug in a point and solve for the leading coefficient, or A, whatever you want to call it, leading coefficient or A. And then our last step is just to rewrite that equation with A. So rewrite your equation from step 2 with whatever A value you got in step 3. So we're going to kind of follow those steps in all of the rest of the examples, but we're just not going to be given these like sentence starters almost of like where to start. So like on a test, what you're going to be given is just write the equation of the graph on the right. So like this first example down here. So step 1, we need to find the zeros. We could look at the end behavior really quick if we wanted. It's up and up. So my degree needs to be even, and I need to have a positive leading coefficient. You can make note of that if you want. You don't technically need it to write your equation. So the real step 1 is to find our zeros. We have x equals -3. What's the multiplicity of that 0 if my graph just goes straight through? 1. Okay. My next 0 is at 2. Again, I'm just looking to where my graph crosses the x-axis. At 2, we have a little bump, a bounce. What's my multiplicity? 2. It would be an x minus 2 squared. And then my last 0 is right here at 5. My graph goes straight through with no squiggle, so my multiplicity is just 1. So that's step 1. Find your zeros. Step 2, write your zeros as your factors. So this is where we write our equation with our A and all 3 of our factors. So if we change the signs, instead of -3, we have x plus 3 to the first power, because our multiplicity is 1. Changing the signs, we have x minus 2 squared and x minus 5 to the first power. And now we need to find A. In most cases, I would say let's pick this point 0, -2 right here. It's going to be super easy to plug in. If you were not already like highlighted this point, I would say just plug this in. It's going to be easier. You could still plug this in, and it'd be easier. For purposes of good math computation skills, let's plug this one in. Okay, either will work. Any point on this line at all will work. But they specifically told us we have this point, so let's use it. So, what should I change y to? What's y? -1. A is just A, because I'm solving for it. And x is 4. So I'm changing all of my x's to 4s. This is technically step 3, where we are plugging in to find A. Okay. On the left, -1. On the right, 4 plus 3 is 7. 4 minus 2 is 2. And 4 minus 5 is -1. 2 squared is 4 times 7 is 28 times negative 1 is negative 28. Final step, divide off that negative 28, and we get A is equal to 1 over 28. And we know that's a reasonable answer because we knew it needs to be positive. So if we got a negative number down here, we would stop, say it doesn't match our end behavior, let's try again because I know it needs to be positive. Something else to just note, even if we know A is negative, when we write this step, we do not write negative A. The negative will come from solving for A. It'll be in A itself. You don't need to add the negative on because you know it's negative. It'll just come out when you solve it. Okay, so always just put A down. So last step is just rewriting this. So 1 over 28 times everything I had up here. So x plus 3, x minus 2 squared, and x minus 5. And that is our final answer. Questions on that one at all? Okay, I want you guys to try to do number 3 for me. We're gonna do one in, the second number 3, typo. I want you to try to do this one for me right above the extra practice. Okay? We'll do the top 2 together in a second. This one with the red red graph. Red graph, second number 3. You don't have color, but you can see the color on my screen. Yes. So take a few moments to try that one. Bless you. Yeah.
When we're trying to figure out if it's a negative or a positive, do we read the left side or the right side?
The right side. So positive for this one. I know, use your Shelly.
Doesn't know her left or her right. That's what I do when I'm driving.
Yeah. I didn't know my left or rights either for a while, so use your fingers.
You can't do that. You need to know your left or right. No.
Saying the driving lady told you that?
No, my best friend.
Oh. No Henry today. That's what we're missing.
When you're trying to figure out if your leading coefficient is a positive or a negative, why would I do that?
Oh, wait, no, it's not.
Why are we doing left to right? Why are we doing why are we leaving right to right?
Yeah.
What? Why are we reading left to right?
Left to right?
Yeah.
We always read left to right.
No, right to
You're not reading right to left. The leading coefficient determines the right-hand side. I know, it's like, we're like kind of starting on the right. I get what you're saying.
Wait,
It's
so-
almost backwards.
Are my arrows correct?
Yeah, so your leading coefficient is positive, because the right-hand side is positive.
Is there only 2? Why are you doing that? Oh my gosh, actually. I know I'm overcomplicating it right now, but
You know your arrows are right one because they match your arrows, right? The right arrow, the one on the right, determines your leading coefficient. So if it's pointed up, it's positive. If it's pointed down, it's negative.
It's only why because this one holds, or why isn't this one clean?
It's just how the graph works out. I don't know the actual figure. But it's just how it works out.
X equals 0.
X is 0. And then your factor is just X out the front.
Oh, it's telling us.
All right, let's, go ahead. I'm trying to check without my key.
What is that?
Maybe I mistake.
Try again. It should be -3 or -3. Other than that,
Like whenever, I guess that's why it hurts.
okay. If we look at my zeros, what's one of my zeros on this graph? X equals 0. There's one right there. I have a bounce at 0. So what's my multiplicity? 2. Okay. My second 0 is at x equals 2. And this one just goes straight through, no squiggle. 1 for my multiplicity. This one's slightly tricky because of this factor right here. How do I write x minus 0 as a nicer factor?
X.
Just x. And where should that x go?
On the front.
In the front. Layla, if you need to close that, feel free.
Oh, it's fine.
Okay.
I should be talking to her anyways.
Fair enough. So we put an x out in front. And the exponent has to be 2. Okay? And then my other factor is x minus 2. And I just need my a value. What is the easiest possible point I could plug in for a? 0. I could plug in 0, 0. Actually, no, I don't want to do that. Time out. Let's try to plug in 0, 0 and see what happens. And here's why we don't really want to do that. If we plug in 0, what am I going to get on the right? 0. We're going to get 0 is equal to 0a. Does that help us in any way, shape, or form? No. So in general, do not plug in your zeros. Pick any other point. In this case, let's pick this point that they already drew on there for us. Let's pick -1, -3. So, if I use this point, -1, -3, y is -3, x is -1. On the right, if we multiply this, what do we get? 1 squared, or -1 squared is +1. This gets me -3. So -3 is equal to -3a. We divide by -3, and we get 1. So, when I actually write down this equation, do I need to change a to anything? No, it's just 1. So my equation is just going to be y is equal to 1 times x squared x minus 2. There's like a hidden 1 in here. We just don't need to write it. Okay? So that's my equation without the 1.
Will you take points off?
No, I won't. Questions on that example? Okay, 2 more. And then we'll do homework time. This one, step 1, find the zeros. Give me one of my zeros. X equals 3, sure, going out of order. 3. It goes straight through 3. What's my multiplicity? 1. Give me another 0. -2. It goes straight through -2, no squiggle. What do we think for multiplicity? 1. And then my last 0? 0. Little tricky, there's no squiggle here. It doesn't get flatter at any point. It's still just kind of going almost straight. Okay, so this is still just a multiplicity 1. It's stretched out a little bit, but it's not actually getting flatter. It doesn't have that flat line. Okay, so that's step 1. Step 2, write the general form of your equation with A. So all of these, we switch the sign, and the exponent is just going to be 1. And for my x minus 0, I'm going to write it as just x out in front. So that's coming from this factor. Next step, pick a point, plug it in. What point should we pick? We have options here, actually. What would be a decent point to pick? There's 2 on our graph.
4, 6.
We have, oh yeah, there's 3 on our graph. We have 4, 6. Let's use that one because they labeled it nicely. We could have also used either of these other 2 gray ones because it actually draws a point on there. But let's use 4, 6 from right here. So y is 6. So 6 is equal to A, x is 4, so times 4. 4 minus 3, and then 4 plus 2. Simplifying the right-hand side, this would be 4 minus 3 is just 1, so this middle term basically goes away. 4 plus 2 is 8, times 4 is 8 times 4?
4 plus 2 is how much?
Oh, 4 plus 2 is 6. Thank you, Preston. 4 plus 2 is 6, times 4 is 24. That's better. 24 is better. Whew. 4 plus 2 is 6, times 1 times 4 is 24. Okay. We solve. Divide both sides by 24. We get 6 over 24. Reduce my fraction. 1/4. Divide top and bottom by 6. Or put it into your calculator and it gives you 0.25. Final step, just rewrite my equation. Y is equal to 1/4 positive. So that makes sense with my end behavior. X, and then x minus 3, x plus 2. Questions on that part? That is the equation. The question says write it in standard form, which may happen. Okay? So what we have to do is FOIL all of this out. Distribute everything. My recommendation, leave your leading coefficient or any x's that are by themselves, leave them for the end. So let's FOIL this first, and then we'll deal with my stuff out in front. Okay? So I'm a little bit out of room. I'm just going to pull this down to this one. Let's FOIL out just the x minus 3 and the x plus 2. If I FOIL, watching my parentheses here, because it's still being multiplied by my 1/4 x. But my first piece, x times x, is x squared. My outside piece, x times 2, is 2x. My inside piece, negative 3 times x is negative 3x. And then my last piece, negative 3 times 2 is negative 6. Before we do anything else, let's combine these like terms in here. So we'll have 1/4 x, and then x squared minus x, 2 minus 3 is negative 1, minus 6. Very, very last step is to distribute this entire 1/4 x to each piece. Okay? So we would get y is equal to 1/4 times 1 is just 1/4. And then we would have an x to what power? What would we do here? What do we do with those exponents? Add them, so x cubed. Still bringing that 1/4 in, minus 1/4 x squared. And then our last piece would be 1/4 times -6. So -6/4 x. We should write 3/2. That's exactly what I was about to say. 6/4 can be simplified. Divide top and bottom by 2, we get 3/2. That is my final answer, only because it specifically asked to write it in standard form. If it doesn't say to write it in standard form, don't worry about it. You don't have to. Leave it like this. But if it says to write it in standard form, you have to take the extra step of actually multiplying everything out. Questions on that one? Okay, let's do one more before homework time. This one is also asking us to write it in standard form, but this one gets a little bit messier when we convert to standard form, okay? So, first step, find my zeros. One's right here at -3. What's my multiplicity at that 0 if it bounces? If it bounces. 2. Is that what you said? Mason, if you're looking for the clock, it's 8:19. Okay, my clock broke, so if you were looking for it, it's not there. Okay, my last 0 is right here at 5. It just goes straight through, so my multiplicity is 1. Okay, next step, write your general equation and find A. So y is equal to A times that factor, if we switch the sign, would be x plus 3. And then again, switching the sign, x minus 5. And the x plus 3 is being squared. Pick a point. If this point did not jump out at me, I would probably pick 0.90 because it'd be nice and easy. But let's pick 150. So 150 is y. X is 2. So 2 plus 3 squared. And 2 minus 5. I'm going to skip the simplifying down. If you simplify this, you would get a -75 over here. And you would divide, and you would get A is equal to -2. Because it'd be 150 is equal to -75A. Divide 150 divided by 2, or 150 divided by 75 is 2. So -2. Okay. Second to last step, rewrite your equation with the A in it. Kind of hard to see right there, but there's my equation. Nick. Yeah. This one's a little more complicated because we have like 3 binomials in here. So I'm going to just rewrite it. First, I'm going to split out, I guess, by x plus 3. Just splitting it to write it twice because it's being squared right now. So I just wrote it twice just so I can get a bigger, clearer picture of what's going on here. And now I'm going to start to actually FOIL. So, goodness, I'm running out of room. I'm going to jump down here. My recommendation for all of these, and we were kind of talking about this earlier, I would almost work from right to left. You guys are more used to like distributing an x plus 3 into something versus a 3-termed something into something else. So let's start on the right, FOIL this, and then we'll distribute this in a second, okay? So, y is equal to -2 times x plus 3 times, if we FOIL, yeah.
Shouldn't it be x?
Was it an x minus 5? Yes, it was an x minus 5. I changed the sign last minute. X minus 5. Thank you, Carolyn. X minus, oh, thank you, Zaina. X minus 5. Okay, back on track. FOIL. First is x squared. X times x is x squared. Outside would be -5x. Inside would be 3x. Add them together, -2x. Okay? Last piece, 3 times -5, -15. Okay. What I also probably should have done is let's just, in this same step, distribute this 2 into this binomial. It's not changing my number of terms, so it's still a nice, easy binomial. So let's just distribute that -2 on the inside. Watching my parentheses because everything in here is still being multiplied. I'm not dropping any of these and changing it to addition. Okay. Here's the tricky part. We need to take each term in this first set of parentheses and multiply it by each term in the second set. So I'm doing -2x times x squared, -2x cubed, -2x times -2x is a positive 4x squared. -2x times -15 is a positive 30x. And that's it for my first term. We have 3 new terms. Now we have to deal with the -6. So -6 times x squared is -6x squared. -6 times -2x is positive 12x. And then the last piece, -6 times -15 is a positive 90. Last and final step, combine like terms. So -2x cubed, he does not have a friend. He stays out in front. Double checking, a that I got was -2, and a is still -2. That's good. 4x squared minus 6x squared is -2x squared. 30x plus 12x is 42x. And then still plus 90 on the end. Questions about that last example? Give me like a thumbs up, sideways, down on how we feel about today in general. Hopefully it was fairly simple. You have a good amount of time to work on your homework. Try to get it done. I might interrupt us with like 10 minutes left and start working on some review things just because we only have one block to do it next week. But for now, you have about 20, 30 minutes to work on your homework. It is a worksheet.